Okay, so today my topic is surface functionalization of concrete via nano-modified releasing agent design. So basically, releasing agent is using in a concrete industry to to easily detach from the concrete surface, concrete from the formwork. So this releasing agent we modified as further we discuss. So this topic we describe mean divide into the five contents. The first one is the role of concrete surface and releasing agent. So role of concrete surface is create beauty of the nature. Uh, concrete surface, if the concrete surface is more good and more smooth, low bulk hole, so this kind of concrete is looking beautiful. The appearance of the concrete will be good. And this concrete surface can get multifunctionalization, just like green buildings in Italy. They prepare a kind of concrete building there that they also uh, growing the plant at every floor. Antimicroorganism property of the surface can get low um, how to say mean antimicroorganism property mean can get good things to save and clean the environment. And the third one is the self-cleaning property. The Jubilee charge is made from the titanium surface coating that is self-cleaning property. The smoke easting property of the concrete surface and the green energy buildings. So the role of concrete surface is in the durability of concrete is a very great effect because deterioration happens from the surface of concrete surface. Just like cracking is also happen from the surface, and acid rain also affect the concrete surface. Carbonization, decolorization, sulfate attack, and chloride ingression. So these kind of problems, it's start from the concrete surface and then go and damage the internal structure of concrete. So for concrete surface improvement to enhance the durability of concrete surface, most researchers are using different surface treatment. But surface treatment have some disadvantage, just like required extra money and extra time. So how to create good and durable surface? So this is our idea that we combine releasing agent with the nanoparticle or nanotechnology to get a kind of good and durable surface. But releasing agent also have some problems, just like releasing agent. Uh, First of all, I want to discuss releasing agent. Releasing agent could prolong the life of formwork, mean it's a kind of waterproof, corrosion resistant, and easily detachment property. So releasing agents are divided into three categories. The first one is vegetable oil-based releasing agent with wood formwork is good for wood formwork. Mineral-based releasing agent with steel formwork can good surface. Water-based releasing agent can get more buxol as compared to the mineral oil. So here, this is the diagram of the mineral-based releasing agent and vegetable oil-based releasing agent, the mechanism that how it is work. So releasing agent can prevent material from sticking to the mold surface. So discuss a short history about the releasing agent. The history of releasing agent from the time of Romans, they prepare a kind of stones and the lime to mix together and then caustic in a mold surface in a mold. But when they remove the mold, so the surface of the concrete is totally damaged. So they use soil and sand to prevent from the sticking. After that, Gustav L. in 1834 used paper for as a releasing agent to not stuck the concrete with the formwork. After that, James Waller in 1884 used tree leaves to get good surface and good and decorative surface. After that, Michael Fasek 1940 used wood grain for easy detachment of the concrete from the surface from the formwork. And in 1900 after that, used dense oil. So what is the effect of releasing agent on the concrete surface quality? So everything has some disadvantages and advantages. So the releasing agent advantages is good quality of surface. Here we see that good quality of surface, smooth surface, and easily cleanable, and labor cost to decrease the labor cost to clean the surface of the concrete and decorative surface here. But the disadvantage of the releasing agent we mentioned here, that it also affect the internal chemistry of the cement. Here we discuss about the effect of C3A hydration and C3S hydration. So in this graph, they use mineral oil as admixture 2% and 6% and 10%, and it show that it decreased the C3A hydration and C3S hydration. Its retardation effect happen. As on the basis of this result, it's also effect on the compressive strength. So in this graph here, they mention that the canola oil, mineral oil, and liquid crude oil they use as a percentage of 2%, 4%, and so many. But it shows that with the addition of this kind of mineral oils or vegetable oil, it's also effect on the strength, on the compressive property of the cement base material. So for this thing, that how to decrease the releasing agent effect in the cement. So for this purpose, we think that can we combine nanotechnology plus releasing agent to get some kind of nano-engineering of the releasing agent. So motivation of this work is why nano-engineer releasing agent. So we have two things for two ideas to get to prepare nano-engineered releasing agent. The first one is using releasing agent sticky on the surface of mold, create hydrophobic or hydrophilic surface of the mold and the concrete surface, and provide pathway for the nanoparticles. And the advantages of nanotechnology, we use two kind of nanoparticles. The first one is nanosilica, is a pozzolanic material, and the second one is nanotitanium dioxide, which used as a self-cleaning property, just like as a photocatalyst and the filling effect in the cement. So how we prepare the nano-engineered releasing agent? So this is a graphical design of the preparation of nano-engineered releasing agent. So first of all, we took a releasing agent and then added nanotitanium or nanosilica into a releasing agent, and then stir for 1 hour at 50 degrees centigrade and sonicate for 30 minutes to get nano-engineered releasing agent. So this is the sample ID, and this is the percentage we added into the releasing agent. So the 4% and 16% titanium dioxide we added, and 2% and 4% nanosilica added into releasing agent to get nano-engineered releasing agent. So first we did the simulation work that that nano-engineering releasing agent and the cement hydration and the hardening property can get good results or bad results. So the addition of RA into the strength on the strength development effect, here we see that the black one is without releasing agent and without modified releasing agent. This is a blank or the reference sample. Here also this is, and this represent S2 and S4 represent the silica 2% and the silica 4%, and the RA, the red one, is represent the releasing agent. Here also, red is represent the releasing agent, and the green and the dark green are used represent the titanium 4% and titanium 16%. So here we see that the all specimens show that the increasing curing edges increase the compressive strength, but releasing agent decreases 27.4% at the 7 days. At 7 days, at the 7 days of curing edges, the compressive strength of the releasing agent decreases up to 27.4%, which indicate the effect of releasing agent on the property of the cement-based material. And the releasing agent can greatly affect on the early edges, but at later age, the effect of releasing agent decreases, and the silica and the nano-titanium property can enhance the property of enhance the compressive property. So on the basis of this, we did some hydration tests, cement hydration. That what will happen there? So in the hydration test, the influence of RA in the cement base on the hydration, on the heat of hydration, the RA induction period delay up to 6.34. Releasing the RA delay the hydration of the induction period 6.3 hour, and T4 and T16 and S4 delay the hydration 4.7 hour and 4.9 hour. And also when it goes to the acceleration period, so the releasing agent delay acceleration period 19.3 hour, and also low heat of hydration heat here. It seems that nanoparticles do not lead higher hydration, but improve the hydration dynamics. Here we see that the nanoparticle can enhance the heat of hydration, but not lead to heat of hydration, but improve the hydration dynamics. After this, we did some water absorption tests. So the first one, at the early edges, this is the 7 days of curing edges water absorption, and this is after 28 days of curing edges water absorption test. So at early edges, the releasing agent can decrease the water absorptivity as compared to the blank, as compared to the nano-modified releasing agent. But why it's decreased the water absorption? Due to the organic in nature, the mineral oil base is basically organic in nature, which protect water from the absorption of water. But at later ages, the releasing agent and the blank sample have higher water absorptivity as compared to nano-modified releasing agent, due to the increase of bound water and also decrease the pore volume or the porosity. So for porosity, we did MIP results, mercury intrusion porosimetry test. So for this test, here we mentioned that increase the nanosilica and the nano-titanium dosage decreases the threshold pore diameter, and the addition of nanosilica in RA can decrease the number of larger pores and also reduce the detrimental pores size, which convert to harmless pores. While the nano-titanium, the size of nano-titanium and the nanosilica is lower, 15 nanometer to 20 nanometer or 25 nanometer. So it goes to the larger pores to decrease the larger pores to the harmful pores convert to the harmless pores. So on the basis of these results, we we conclude that this releasing nano-engineered releasing agent can get good surface property. So on the surface quality improvement for improving the durability, we apply on the surface of the formwork. Here we see that the nano-engineered releasing agent apply on the mold surface, then put in the mold, and then cast the concrete. And after concrete, this is the two finished concrete. This is the normal concrete, mean this is the releasing agent, and this is modified releasing agent. So clearly it shows that the color of the both concrete is totally different. And also here we see that there is a lot of bulk sold as compared to the modified releasing agent. So it shows that, yeah, there will be some good effect on the concrete multifunctionalization. So for this purpose, we did surface porosity analysis. But for porosity analysis, we cut from the surface till to depth 2 millimeter surface, and we did this MIP test. So in this here, we see that the releasing agent it mentioned here is the blank or the black one. It shows that the total porosity of the releasing agent is 11.85%, while the S4 mean the silica 4 and the titanium 16 is 9.5% and 9.61%. So the total porosity of the nano-modified releasing agent is lower than the releasing agent. And the cumulative pore volume and the threshold volume is reduced due to the filling effect of nanotitanium and also the pozzolanic effect of the nanosilica. So after this, we did some durability tests to summarize that is it if it create durable concrete surface or not. So sulfate resistivity analysis mentioned that after 28 days of curing, all samples immersed in 5% sodium sulfate solution for 120 days. From initial immersion to 90 days, from initial to 90 days, all samples increase the strength. This could be due to the continuous hydration and the compactness of the surface microstructure due to the formation of expensive agent in the surface, on the surface, sorry. But after 90 days, here we see this is the mass changes and this is the compressor strength. So the compressor strength after 90 days to 120 days is goes down, mean it's decreased, and also the mass changes also have lower effect, but there is a negligible effect. So it shows that after 90 days, the expensive agent can erupt, can enhance, the expensive agent formation is more. So that's why the pore volume increases. That's why the compressive strength decreases. So the mass loss here we see that the 0.55% is of the mass loss after 120 days, and the titanium and silica 4%. The mass loss is 0.461% and 0.54%. So what will happen? After this we did some another porosity test for the sulfate resistivity samples. So here we see that the total pore volume before and after 120 days, before the total pore volume 11.85%, but after 120 days 10.64%. So it means the expensive agent is decrease the pore volume, but and also in the silica and the nanotitanium modified releasing agent, it also decreased 8.67% and 8.76%. But the total changes here, 10.21% and 8.73% and 8.844%. It is because of the expensive agent formation. So it shows that the sulfate attack resistivity of the modified releasing agent is better than the releasing agent. So this is conclusion that that the counterbalance of the adverse side effect of releasing agent on the property of cementitious material with nanoparticles. And the second one is economical and efficient improvement of concrete durability through surface modification with nano-engineered releasing agent. And we published these two papers. One is CCR, one is CBM. Thank you.
Thank you a lot. Appreciate for your excellent presentation.